Hello, everybody. For this video lesson, we're going to be learning about fractional exponents and radicals. Okay, so before we get going with that, I'm just going to do a little exercise here. So using your calculator, you're going to determine each of the following values. So we have our x volume, here. And then on the right column, we're doing an operation to x, okay? So we're just raising it to the exponent 1 over 2, okay? So 1 to the exponent 1 over 2 is equal to 1, okay? So please pause this video and feel free to fill out the rest of this table on your own, please. Okay, so 4 to the exponent 1 over 2 is equal to 2. 3 to the exponent 1 over 2 is equal to 3, 4, and 5. 1 to the exponent 1 over 3 is equal to 1. 8 to the exponent 1 over 3 is equal to 2, 3, 4, and 5. Okay. Hopefully at this point you're like, Jones, I recognize these. These are like the cube roots of the numbers that we're taking the exponent of the 1/3, or the square roots of the numbers that we're taking the exponent of 1/2. Well, that is because if we are taking a number to the exponent 1 over half, it is the exact same operation as taking the square root, okay? So what operation is the same as x to the 1/2? Is taking the square root of x. Okay, and what operation is the same as x to the exponent 1 over 3? So that is taking the cube root. Okay, so the cube root of x. Okay, so from that, we can derive a general rule. So when n is a natural number and x is a rational number, whatever the denominator of the fractional exponent is the index of the radical. Okay, so the denominator is n, so n is the index. And then the numerator of the fractional exponent is the exponent that goes on the radicand. Okay, so x to the exponent 1 over n can be written as a radical as taking the nth root of x to the exponent 1. Okay, so again, the denominator of the fractional exponent is the index of a radical, and the numerator is of the fractional exponent is the exponent of the radicand. Okay, so whatever is underneath the radical. Okay, so let's evaluate these without using a calculator. And you can use either the perfect square or the perfect cube method, or you can do the prime factorization method. Personally, I like doing the prime factorization method because it doesn't really involve a deep memory of the perfect squares or the perfect cubes. So I'm going to use prime factorization when I do these, but you're more than welcome to use the perfect square strategy as well. Okay, so 27 to the exponent 1 over 3. So remember, the denominator of the fractional exponent is the index of the root that we're taking. So we're taking the cube root of 27 to the 1. Okay, so remember, the numerator of the fractional exponent is the exponent that belongs to our radicand. Okay, so we can rewrite just that as the cube root of 27. Okay, so let's do our factor tree for 27. And because we're taking the cube root, we're looking for groups of 3. okay, which is awesome because I see a group of 3 right there. So the cube root of 27 is just equal to 3. Awesome. Okay, so for our next one, so we have 0.49 to the exponent 1/2. Okay, so let's rewrite this as a radical first. Okay, so the denominator is 2, so we're taking the square root of 0.49. Okay, we're taking the square root of a decimal here. So remember, anytime we're taking the square root of a decimal, we should rewrite it as a fraction. So 0.49 is 49 hundredths. So that equals the square root of 49 divided by the square root of 100. Okay. So now let's go ahead and simplify that. So the square root of 49, I know that is 7. So if you know those square roots, you don't really have to worry about the factor tree. But if you need to show your work, show your work. Okay. So square root of 49 is 7. Square root of 100 is 10. And then if you want, you could convert that to a decimal. Okay, 0.7 for that one. Okay, so negative 64 to the exponent 1/3. So we're taking the cube root of the negative 64. Okay, let's do a factor tree for 64. So we got 2, 32, 2 and 16, 2 and 8, 2 and 4, 2 and 2. Okay. I have 2 groups of 3 here. So I'll do this in 2 steps, okay? So this equals cube root. Anytime you have like a negative there, you can just kind of like put it to the side and just remember that it's a negative. Because we're taking the cube root, we're just multiplying a negative number by itself 3 times. Okay, so here we have 2 times 2 times 2 times 2 times 2 times 2. Right, we had 6 2's over there. Take out a group of 2, so equals 2 cube roots of 2 times 2 times 2. Now we'll take out that other group of 2. Don't forget to multiply that 2 out front. So the cube root of negative 64 is going to equal negative 4. Okay, we multiplied that group of 2's we just took out by the 2 that we already took out, and then don't forget about that negative answer. Okay, this last one, feel free to try on your own if you'd like. So we have a fraction and a fractional exponent. So let's deal with the fractional exponent first, and then we'll deal with the fraction side. So to the exponent 1/2, so we're taking the square root of 4/9. And anytime we're taking the square root of a fraction, remember we should take the square root of the numerator and the denominator separately. Okay, and the square root of 4 is 2, and the square root of 9 is 3. All right. Okay, so to give meaning to a power such as 8 to the exponent 2/3, where the numerator of the fraction is something other than 1, think about what this exponent means. So I know I kind of mentioned it earlier. So if we had, for example, 4 to the exponent 1/2, so remember the denominator of the fractional exponent will be the index of the root that we're taking. So we're going to be taking the square root of 4, and then the numerator of the fractional exponent is the exponent on the radicand. Okay, so in all the examples we've done so far, the numerator has been 1. Okay, Now, in this example, and in some examples that you're going to be dealing with going forward, the numerator of the fractional exponent might be 2, and that's okay. We're just going to put that as the exponent as the radicand of the radicand. Okay, so let's put that in words. The numerator of the fractional exponent becomes the exponent of the radicand. Okay. The denominator, I know we've talked about this, but let's put this words here. The denominator of the fractional exponent is the index of the radical. Okay, so the denominator becomes the index. Okay, and the numerator becomes the exponent of the radicand. So if we analyze 8 2/3, okay, the index is going to be 3, okay, because it's the denominator. So we're taking the cube root, and we're taking the cube root of 8 squared. Okay. Great. So let's go ahead and solve that. Now, so let's just go ahead and square that right now. We'll talk about that in a little bit more. Okay. So 8 squared is 64. So we're taking the cube root of 64. Do a factor tree for 64. 2, 32, 2, 16, 2, 8, 2, 4, 2, 2. 2 groups of 2, so 2 times 2. So the cube root of 8 squared, that equals cube root 2 times 2 times 2 times 2 times 2 times 2. 2 groups of 2. So the cube root of 8 squared is equal to 4. Or 8 to the exponent 2 over 3 is equal to 4. Okay, so just a general rule. Okay, so paraphrasing what we've just talked about on the last slide. So x to the exponent m over n is equal to the index of n, where x is to the exponent m. Okay. And in other words, we could say this as we're taking the nth index of x to the exponent of m. Okay. So what we're saying here is that you can either put x to the power of m and then take the nth root to solve for that, or to simplify for that expression, or you can take the nth root of x and then take the square root of m, or and then square it to the power of m. Okay. what that means in this example here. So we squared 8 before we took the cube root of it. We could have also taken the cube root of 8, which is 2, and then squared it after. So 2 squared, which is 4. We get the same answer, okay? 2 ways to do it. It doesn't matter what way we do it. Personally, I think it's easier to take the nth root of x first and then raise it to the power of m. It's just going to give us a smaller number to take the root of. But the decision is yours. Okay. So let's go ahead and use those rules to write these fractional exponents as radicals, or radicals in fractional exponents in various ways, okay? So 40 to the exponent 2/3. So fractional exponent, remember, the denominator of the fractional exponent is the index of the root, and the numerator of the exponent is the exponent of the radicand, okay? So we can write it that way, or the other way we can write it, instead of squaring 40 and then taking the cube root of that, we can take the cube root of 40 and then square it, okay? So personally, I think it would be easier to take the second strategy, take the cube root of 40 and then square it, instead of squaring 40 and then trying to find the cube root of that. Okay, so next we are writing the square root of 3 to the exponent 5 in exponential form. Okay, so remember the index will form the denominator of the fractional exponent, and the exponent of the radicand will form the numerator. Remember, if you don't see a number on the index, we are taking the square root. So because there's no number, we're taking the square root. So 3 is our base, the denominator is 5, and the numerator is 2. Okay, so 3 to the 2/5. And I have that mixed up. Sorry. The index of the root is the denominator, and the exponent of the radicand is the numerator. My apologies. Okay. Writing the cube root of 25 squared in exponential form. So we could also write this as the cube root of 25 squared here. And remember, the index of the root is the denominator of the fraction. So over 3. The exponent of the radicand is the numerator, and the base is 25. Okay, so be able to convert from a fractional exponent into a radical, or from a radical into a number with a fractional exponent. Okay, so a fraction can also be written as a decimal. So remember, to convert a fraction to a decimal, you just put it into your calculator and press enter. Right, so 3 divided by 4, or 3/4 is a fraction, is 0.75. Okay. Yeah, so if you have a decimal as a exponent, it's best to convert it into a fraction, and then you can convert it into a radical. Okay. So here we are. So we have -27 to the exponent 4/3. So we are taking the cube root of -27 to the exponent 4. Okay, I'm going to take the cube root of 27 first, and then raise that to the power 4. Okay, so when it's a negative, you can just kind of leave it outside for a minute. Okay, don't forget about it. But leave it outside when you're doing your factor tree. Okay, so 27 breaks down to 3 and 9, and 3 and 3. So the cube root of negative 27 is equal to negative 3 to the exponent 4. Okay, so we can simplify that further. So negative 3 times itself 4 times. So negative 3 times negative 3 is 9. Times negative 3 is negative 27. Times negative 3 is positive 81. Okay. Next, we will do 81 to the exponent 3 over 4. Okay, so the denominator of the fractional exponent tells us the index that we're taking. So we're taking the 4th root of 81 to the exponent 3. So 81 can be broken down into 9 times 9 and 3 times 3. Okay, so the 4th root of 81 is 3. And then 3 cubed. 3 times 3 is 9. Times 3 more is 27. All right. And don't let me forget about my negative. Oh, no, that was good. Okay. Good. All right, so I would encourage you to try these on your own. Note that they are decimals. So I would recommend converting them into fractions over 100, right? Because that's 400ths and 100th. So feel free to pause this video and try these next 2 examples on your own, please. So 0.04 to the exponent 3 over 2. So we are taking the square root. Let's turn 400ths into a fraction first. So 4 over 100 to the exponent 3 over 2. So we're going to be taking the square root of 4 over 100 cubed. Remember, anytime you are taking the square root of a fraction, or taking the square root of a fraction, we should take the square root of the numerator and the denominator first. That equals the root of 4 divided by root of 100 cubed. Square root of 4 is 2. Square root of 100 is 10 to the exponent 3. Okay. So then we have to multiply 2 over 10 by itself 3 times. Before we do that, let's reduce that fraction to make our lives a little bit easier. So that is going to equal 1 over 5. 2 divided by 2 is 1. 10 divided by 2 is 5. One times 1 is 1. 5 times 5 is 25. Times 5 is 125. Okay. So let's convert this into a fraction first. So 100th is 1 over 100 to the exponent 3 over 2. So we're taking the square root of 1 over 100 to the exponent 3. take the square root of the numerator and the denominator separately. So 1/10 cubed. And then multiply that by itself 3 times. Ten times 10 is 100. Times 10 is 1,000. All right. All right, so we have a decimal exponent now, so 0.4, so 4/10. So let's go ahead and change that into a fraction. Okay, so that equals negative 32 to 4/10. Always reduce our fractions if possible. Okay, so 4/10 can be reduced by a factor of 2, so equals base is the same, 2/5. So we're taking the 5th root of negative 32 squared. Okay, let's see what 32 breaks down into. 2 and 16, 2 and 8, 2 and 4, 2 and 2. All right, awesome. So we have a group of 5. We're taking the 5th root. So the 5th root of negative 32 is negative 2 squared. Negative 2 times negative 2 is equal to positive 4. All right, hopefully you're starting to get the hang of it. Again, if you're struggling with this, please send me an email. I'd be happy to help you. Okay, so here we have a word problem and we're given a formula. So biologists use the formula B is equal to 0.01 m to the exponent 2/3 to estimate brain mass, B, in kilograms of a mammal with body mass M. Okay, so B is body mass and M is, B is mass of brain and M is mass of body. Okay, so this formula is showing the relationship between body mass and brain size or in brain mass. Okay, so we're supposed to estimate the mass of each animal. Okay, and let's do this without our calculator for the husky. Okay, so B is equal to 0.01 m to the exponent 2/3. Okay, so what are we doing to our m? We are taking the cube root of m squared. Right, the numerator is 2, so we're squaring m, and the denominator is 3, so we're cubing that. Okay, so for a husky, mass is 27 kilos, so let's substitute that in for m. So B is equal to 0.01 cube root of 27 squared. Cube root of 27 is 3. 3 squared is 9. And this is all in kilos. So the brain size of a husky is going to equal approximately 0.09 kilos. Okay, for the polar bear, feel free to use a calculator for this one. Our mass is 200 kilos. We can see if we get the same answer. So B is equal to 0.01 m to the 2/3. Okay, same formula. We're still squaring the cube root of m. And m for my polar bear is 200. Okay, so let's see what 200 breaks down into. Two and 25. Yeah, so that's not gonna give us a nice perfect cube. So cube root of 200 squared is 34. And the brain of a polar bear is going to be approximately 0.34 kilos. Okay, so in a couple of these examples in your practice problems, you just have to do a direct substitution using that formula that is provided. So make sure you are reading the question and reading the information thoroughly in the question that's provided. Again, please reach out if you have any questions. Thanks again for your attention, and we'll see you later.